This is the story of the quest for knowledge and the urge to understand the natural world. The story of boldly exploring uncharted terrain. The story of scientific investigations to enrich the realms of science with newfound treasures. This is the story of the National Physical Laboratory, an institution of science set up for the country's development and to give a push to the fledgling Indian industry immediately after independence. A story that just has a beginning and no end. Realizing the importance of science in nation building, the scientific and political leadership of the country decided to create an array of institutions for producing scientific knowledge. National Physical Laboratory was one among the first to be created under the umbrella of Council of Scientific and Industrial Research just after independence. Pandit Jawaharlal Nehru laid the foundation stone of NPL on 4th January 1947. And it was declared open on 21st January 1950 by Sardar Patel.
The National Physical Laboratory has the mandate by an Act of Parliament to maintain and upgrade continuously by research the national standards of measurements. We provide apex level calibrations in the areas of 7 primary variables like mass, length, time, temperature, electrical current, the intensity of light candela, and the amount of substance mole. We have state-of-the-art facilities to provide primary standards of vacuum, pressure, photometry, dimensional metrology, measurements of electrical resistance, electrical voltage, acoustics, humidity, measurements of RF and microwave radiation, measurements of electrical power, as well as providing calibration for high voltage AC and DC transmission. Now, leaving aside the standards related activities, about 60% of the NPL scientists and technical officers are engaged in cutting edge research in the frontline areas of energy harvesting, development of new engineering materials, nanoscience and nanotechnology, understanding our environment using radar and LIDAR based techniques. We are also studying the polar environment, particularly at the South Pole, where NPL has a permanent laboratory which is manned by our scientists around the year. We also have frontline research in the area of quantum physics, quantum measurements, particularly of ultra-cold electrons, photons, and atom ensembles. In addition to these standards as well as research-related activities, we also have a vibrant academic program. We provide MTech degrees as well as Master of Technology. The total cumulative student strength at NPL today is roughly about 200.
Set up with a focus and a vision for the realization and maintenance of national standards for physical measurements, NPL is dedicated to apex-level research and development. Based on research, the organization has a clear mandate to standardize, calibrate, and test that it follows and abides by diligently and persistently. To establish, maintain, and improve continuously by research for the benefit of the nation, national standards of measurement, and to realize the units based on the international system, to identify and conduct, after due consideration, research in the areas of physics which are most appropriate to the needs of the nation, and for the advancement of the field to assist industries, national and other agencies in their developmental tasks by precision measurement, calibration, and development of devices, processes, and other allied problem related to physics. The 7 arms of NPL have consistently worked towards keeping it at the forefront of innovation, globalization, and social development.
National Physical Laboratory maintains the national standards to meet the requirements of Legal Metrology Act. It provides apex-level calibration services in the country. The national measurement standards and the calibration certificates issued by the laboratory are internationally recognized. It also helps the other labs in their precision measurements and calibration of instruments. The international unit of mass is kilogram, realized through an international prototype of 1 kilogram that resides at International Bureau of Weights and Measures, France. Responsibility of maintaining the national prototype of kilogram rests with NPL. The primary standards of derived units of volume, density, and viscosity are also maintained right here. SI unit of meter is realized here through iodine-stabilized helium neon laser operating at 633 nanometer. This electromagnetic radiation is used for dissemination of traceability to dimensional measurements through interferometry. A traceable 3D optical profiler has also been established as part of NPL's endeavor on generic development of nanometrology for nanotechnology. Temperature standards are maintained by realizing triple point of water and equilibrium states of pure substances. NPL provides calibration traceability in the range from 84 Kelvin to 3000 Kelvin. Humidity standard is maintained by 2P-based humidity generator capable of providing calibration of hygrometers in the range from 10% to 95% RH.
The National Physical Laboratory is also the custodian of the Indian Standard Time, IST. The International Time Scale takes input from the Indian Time Scale, which is based on 4 cesium atomic clocks and 1 hydrogen mesa. To compare the time with clocks located in Japan, Germany, China, and Korea, two-way satellite time and frequency transfer systems have been developed. NPL has recently developed a laser-cooled cesium fountain clock, which will lose or gain 1 second in several million years and puts India in the elite club of 6 developed nations having such a standard. For the Indian satellite-based navigation system, NPL in collaboration with ISRO has developed a rubidium atomic clock model at whose core is a rubidium bulb and an absorption cell.
Detector-based chirogenic radiometer and source-based blackbody function as primary standard for optical radiation. Optical Radiation Standards Research Lab is a national measurement facility for the photometric parameters: luminous intensity candela, luminous flux, luminance, illuminance, illuminance responsivity, color coordinates and color temperature are measured here. Scientists also calibrate light sources, illuminance meters, colorimeters here.
Coming to the electrical parameter, NPL scientists are busy using the Josephson effect-based quantum voltage standard to realize and disseminate the unit volt in the country at par with the international standards at 1 and 10 volt levels. Scientists here maintain a national centralized facility to generate electrical resistance standards based on quantum Hall effect. The unit of electrical resistance is disseminated to other agencies throughout the country. Using state-of-the-art instruments, scientists calibrate current transformers in the range of 5,000 amperes to 1 ampere and voltage transformer ratios up to 100 kilovolts by 100 volts. Calibration and measurement of AC high voltage capacitance and tan delta exists up to 200 kilowatts. The primary standard of capacitance is traceable to the base unit length. A 10 picofarad silica capacitor is used as a national standard. The unit of inductance, Henry, is realized from this standard capacitance. Sophisticated yet robust, primary standards of AC voltage, current, power, attenuation, and impedance have been established to provide calibration services in the range of 10 Hz to 18 GHz. Broadband voltage standing wave ratio measurement facility also exists in the same frequency range.
Analytical Chemistry Lab. It focuses on SI mole traceability and chemical measurements. It has facilities of inductively coupled and other sophisticated mass spectroscopy techniques for elemental analysis at ppb and ppt levels in water. The technique is also used for any certified reference materials. NPL is also maintaining various derived units. It has developed pressure standard facilities. Industrial and pressure gauge systems are calibrated here. Scientists are maintaining vacuum standards by following 3 primary standards. In order to conform to the international standards, ultrasonic interferometer, static expansion apparatus are used. Facilities have also been established to calibrate the reference devices of force, torque, and hardness parameters to the highest international standards. The primary standards of sound pressure, ultrasonic power, and vibration amplitude are maintained to the highest levels of accuracy. It serves the country in calibrating microphones, sound level meters, accelerometers, vibration meters, ultrasonic NDT equipment, and testing of acoustic materials. Based on NPL advice, measures have been taken such that vibrations produced by metro rails do not affect nearby buildings. The fluid flow facilities consist of primary and secondary standard of water flow, which are based on weighing and volumetric methods respectively. The country needs to establish the primary standards of magnetic field. These are maintained in the range of 1 microtesla to 1.5 Tesla. It is here that electric steel power loss measurements are also carried out from 1 Tesla to 1.8 Tesla.
The Physics of Energy Harvesting Division is developed cost-effective, energy-efficient, and stable materials and devices. Here, scientists are working on technologies for harvesting solar energy and utilizing it for efficient lighting devices. Organic photovoltaic and thermoelectric materials and devices-related research is highly promising. NPL scientists are dedicated to developing these cutting-edge technologies. Plasma-processed amorphous microcrystalline and nanocrystalline thin films are prepared and characterized in the lab using plasma-enhanced chemical vapor deposition system. We have successfully fabricated thin film silicon solar cells. Scientists are dedicated to developing both inorganic and organic light-emitting devices as well as nitride-based solar cells using molecular beam epitaxy growth and multi-probe systems to characterize them.
The Material Physics and Engineering Division is dedicated to the development of novel alloys and nanocomposites for structural and thermoelectric applications, advanced carbon products for energy and strategic applications, corrosion-resistant paints and lightweight battery electrodes, nanophosphors for energy-efficient lighting, functional and flexible ferroelectric liquid crystals for faster electro-optic response, biomarkers and biomolecular electronics for efficient biosensors. NPL has also created a facility to produce continuous carbon nanofibers by electrospinning for applications in aligned CNT composites, antibacterial activities and purification of water. NPL has developed accelerometers with typical reference sensitivity of 20 millivolts per G in the frequency range 10 Hz to 10,000 Hz for measuring vibration and shocks up to 3000 G. Medical Instrumentation Group is working on the development of biosensors for diagnosis of glucose, cholesterol, urea, etc. Work is also being done on cancer diagnostics and infectious diseases. The Metals and Alloys Group is engaged in the design, synthesis and characterization of novel alloys, nanoalloys and nanocomposites for energy generation and its effective utilization. Special alloys are also being developed to make nanostructured permanent magnets.
The study of quantum phenomena and applications involves major areas of physics related to the Josephson's junction, single electron tunneling, quantum transport in thin films, and heterostructures, nanoscale measurements, quantum optics, photon physics, and superconducting material. A network of highly sophisticated labs carries out these activities.
Low temperature research down to 1 Kelvin was initiated by Dr. K.S. Krishnan in 1950. Dr. David Schonberg, FRS, spent a year here, and first liquid air plant was installed under his guidance. A helium liquefier was commissioned in early 1952. This facility was first of its kind in the country. With the passage of time, this facility became obsolete. The demand for liquid helium arose steeply because of research in metrology programs such as Quantum Hall Resistance Standard, Josephson Volt Standard, and fundamental research in the area of low-temperature condensed matter physics, superconducting electronics, and spintronics. Our relentless efforts since 2010 for renovation of this facility have yielded fruits, and with one-time grant from CSIR, a new helium liquefier, model Linde's L70, has been procured, installed, and commissioned in a record time.
5 PLD chambers along with the integrated magnetron sputtering and thermal evaporation facilities are used to develop magnetic tunnel junctions, magnetic and superconducting films, heterostructures, and 2D oxide interfaces. A highly specialized characterization facility to measure electrical, thermal, and magnetic properties of materials in a temperature range of 1.6 to 350 K and a high magnetic field range of 0 to 14 Tesla has been established here. This quid-based magnetometer can measure magnetization with a degree of precision in the temperature range of 1.8 to 400 K and a magnetic field range of 0 to 7 Tesla.
Sophisticated Analytical Instruments Division plays a vital role in rendering characterization services for advanced materials like single crystals, nanocrystals, polymers, ferrofluids, epitaxial, porous and amorphous films. The characteristics that are evaluated here include chemical composition and purity, trace elements, crystalline structure and perfection of structure that controls their properties. This division also develops advanced materials of bulk single crystals, nanomaterials, polymers and ferrofluids. In-house developed multi-crystal X-ray diffractometer analyzes the crystallographic orientation, curvature measurements and defect structure by diffuse scattering. EPR spectrometer provides information about electron concentration and nature of interactions between defects and surrounding molecules. Further, it provides information about magnetic anisotropy quantum and spin wave phenomena. The facility is equipped with X and Q band and UV irradiation attachment. It is here that scientists use magnetorheometer to investigate the rheological, viscoelastic, triobiological and dielectric properties of materials. It has been used here in the development of nanomagnetic fluids and devices for applications in energy conversion. Scanning electron microscope (SEM) with an attachment of energy dispersive spectroscope studies the materials for surface morphology, grain or particle size shape distribution, presence of second phase particle and chemical composition at the micro and submicron level. And this microscope, called scanning probe microscope, is meant for studying surface morphology and surface roughness investigations.
The Radio and Atmospheric Sciences Division of NPL caters to the scientific need of the nation in the area of radiophysics and applications, space weather and ionosphere, chemistry and physics of the Earth's atmosphere, atmospheric pollution and climate change. It is at NPL that we carry out advanced ionospheric research for studying radio propagation for the purpose of improving radio communication, navigation, and many other applications.
No amount of sophisticated equipment and facilities could ever contribute to the expansion of scientific and technological knowledge. It is creative human brain that generates the knowledge. National Physical Laboratory places high premium on this bubbling cauldron of brain power. Highly dedicated, motivated, creative and innovative scientists constitute the backbone of this gigantic knowledge-producing laboratory. Generations of scientists have contributed to nation building, and nation in turn has acknowledged their contribution by bestowing individual, group and institutional awards. Touching the horizons of ever-expanding knowledge, National Physical Laboratory marches on confidently.
CSIR NPL now looks forward to start a vibrant program in the areas of fundamental physics of quantum systems, nano devices made out of semiconducting and superconducting heterostructures, layered compounds like graphene and transition metal dichalcogenides, and a new class of energy harvesting technologies. The standards-related activities of NPL are peer-reviewed by the best in the world. We have a quality system in place. We are visited regularly by distinguished scientists from BIPM France, the National Institute of Standards and Technology in the United States, PTB Germany, National Metrology Institute of Australia, as well as various other European bodies. We are looking forward to have new metrology-related activities, particularly in the areas of metrology and chemistry and metrology and standardization of biomedical instruments. In the area of human resource development, the MTech and PhD program moving very well. We all are working with enormous energy, vigor, and a spirit of teamship to climb the greater heights of science, technology, and innovation. Thank you for watching this video, and thank you for visiting CSIR NPL.
No wonder the laboratory has won innumerable awards and recognitions. NPL has built around it an aura of success, moving ahead confidently and assured of its ever-rising curve of innovation. NPL is marching forward from strength to strength.